Hello, we are back with the landcruiser Prado diesel 1kZTE motor, and we have a little issue with the EGR system. So you can see over here my finger is the actual EGR valve, and the problem I'm having, which I can't find any information on, it seems like nobody else has had this problem, is when this line right here that goes to this tan solenoid is hooked up. This is just a filter, by the way. When it's hooked up to the EGR valve, once the car gets hot, heats up to operating temperature, it's way down on power. There's black smoke everywhere at all times. But when you disconnect that line from the EGR valve, everything's fine. So we're going to do some tests. We've got some vacuum testing here with a vacuum gauge. And we're going to test the EGR valve in the system and the solenoid as much as the FSM says, see if we can see any discrepancies. Otherwise, just cap off the EGR valve and technically eliminate it without actually blocking everything off. So in addition to that, we're going to speak a little bit about the injection pump down here. I solved a problem with a leaking crank sensor, which is this top sensor here. Oops. This sensor basically detects when the engine is rotating. So there was an O-ring here leak, and then this top cover also has a gasket. We didn't replace it. It's not leaking, but I'll put part numbers in here for all that, because it seems like a little bit of a secret. People kind of, I don't know why, but they guard the part numbers of, you know, all this stuff, the seals and whatnot. I don't know why that is. It's very hard to find information on everything. And we'll kind of go over the different valves here. The spill control valve is on the right. This adjusts global fueling all around. There are two resistors here, this gray and orange plug, which have to do with idle. There's a temperature sensor right here on the right, fuel temperature sensor. And then way down on the bottom, there's a timing control valve, which also has something to do with timing and fuel delivery. We'll kind of talk about it all, just kind of as a bonus to the EGR problem, because we dealt with that. But that wasn't too big of an issue. But primarily, I just want to get the part numbers and stuff visible for that. But we'll go over that after this, kind of at the same time. I'm not sure where it'll fall in the video. But first, you will need a vacuum and fuel pump pressure tester. You can get this on Amazon or wherever. It's basically just a big giant gauge that has all sorts of different values. Vacuum, what else is in here? Normal motor, it says. I don't know what that's referring to, but you've got PSI, so up to 10 PSI here. You got vacuum, all sorts of different graduations and hash marks and all that stuff. So essentially what we need to do is put a T on this line here, hook it up to the EGR gauge, start the motor, see what the gauge says. So let's do that. Alright, so we got everything hooked up, the vacuum gauge. What it says here is basically on a cold engine, the gauge should be 0 at idle. So at this point we turn the car on. Vacuum gauge should read 0, and our vacuum, I guess it should just be 0 regardless, because 0 is 0 is 0 on all the gauges. So we'll set this right here, and hope this will sit somewhere. Let's hang this around there. There we go. Alright, so it should be 0 when we start. There we go. But it wasn't 0 to begin with. So I don't know if the gauge is not functioning correctly or what. I would assume this would be here, but I don't know. It's all hooked up. Alright, well, we'll wait for this to heat up, because when the car heats up is when we have problems. So we'll see if this changes, because it's saying at when it warms up here, the vacuum should read 28 kPa or 8.3 inches of mercury here at idle. So when it warms up, technically we should be in this region, because that would be 8 Hg of mercury, or inches of mercury. And then when you let's see here, and then when you go to 1500 RPM, it should go larger than, so it should go more than that. And then when you let off, it should go back down again. So we'll see what happens when it warms up. But I don't know if this thing's defective or what's going on, or why it's reading more than 0 at 0. So we'll see. Okay, at this point we're warmed up, and now it says the vacuum gauge indicates more than 8.3 inches of mercury at idle. So is more than greater than 0, or more than is greater than like more vacuum? That I'm not sure of. When the accelerator pedal is quickly depressed to the full open, check that the indicator drops momentarily and comes back up. So it looks like we build a vacuum when we hit the accelerator, which is kind of weird. That's not normal. It's all the way down at 20 inches of vacuum. And go slowly back up again. Is it going to stop at 8? No. Huh. So that's interesting. Engine speed at more than 4,000. I'm not going to do that, but it should be 0. I mean, I guess. What's weird is this. Look at that. I don't think that's normal. So that's our problem. I just need to figure out what the problem actually is. Very weird. Okay. So that's not normal. It shouldn't be building vacuum as you rev it, I don't think. Some of this now, you're going to have to remove the EGR valve to test, and ohmmeter, check resistance between the terminals of the lift sensor. I don't think this has that. Maybe I'm mistaken, but I don't think those are on the EGR valve, so some of this might not apply. So really the only thing we can do is stick a vacuum gauge onto the EGR valve on the top port up here, and just kind of see if in fact we can hear anything, or detect any kind of weird anomalies. But that doesn't really help me diagnose the problem here. Is it this VSV down here? Is that the problem? I would have to get something to check it, maybe apply power to the terminals. Let's see if it clicks on and off. That's really all you can do to test that without the actual FSM on, vacuum testing and all that, and terminal resistance. So let me throw a vacuum gauge on here, or a Mityvac. Okay, I've got the Mityvac hooked up to the EGR valve here, and we can give it all the vacuum in the world, and it holds it. So, and I can actually hear it actuating. Let me get a microphone on here so you can hear. You can probably hear it already, but whatever. Hold on one second. Test. I'm going to put a microphone right here by the EGR so you can hear it. And I think I just heard it there. And then we will release. There. So, it appears that your EGR valve works, as we can hear it moving. So we can assume that it is opening and closing, or it can open and close, and the problem is probably not the valve itself. So without further information, a common thing to do is just to block off the EGR system. There's no check engine lights or anything. You leave all the solenoids attached. And let's see here, how can we do this? We could either remove this line from the... Okay, it just kind of falls off. Solenoid, I wonder if someone took this off at some point. Well, either way, we're going to put a cap on here, and then a cap on the top valve. And then call it a day, because that's kind of the solution I had before. This whole madness. So we're going to take our massive 165 piece vacuum cap assortment here, and hopefully this doesn't spill all over the ground. It comes with a nice assortment of vacuum caps, more than you'd ever need for all your projects. And I'm going to stick one right here on the top of the EGR valve. Not really necessary because I don't think that goes anywhere. And then we'll stick one, probably can't see, but realign the lighting. Then I'll stick one right on this port, on this brown valve down here, because this is what went to the top of the valve. And that's it. We're going to call it a day. EGR problem fixed. So if anyone has any tips or advice on this, on what this might be, I don't think it has to do with carbon deposits or buildup, because it's just when it gets hot. So I think when it gets hot, it actuates, something turns on or actuates, and then either causes this to open at all times or go full open, thus just creating an open path from the exhaust to the intake and intake back or whatever. But I'd like to figure it out properly and actually deal with it. There's another valve, like an electronic valve, under the EGR valve, or the EGR, whatever this is. There's an electronic, setup. So I don't know too much about these systems on diesels, but if you have any advice, that's broken. Yeah, let me know, because I'd love to fix this the proper way. But, next, or maybe I already talked about it, but I will get this, talking about this fuel injection pump here, and then post those part numbers. Alright, welcome to the Bosch style injection pump. So we have a fuel leak coming from this top sensor. I think this is the crank sensor, the signal that detects cranking. There's a lock nut here, and unfortunately there's an o-ring on the sensor, but the o-ring is inside this top hat. So the risk you run, if you remove the top part, then put that back on, that might leak. But either way, we have a dilemma, because it appears these o-rings for this pump are relatively difficult to buy separately. You can buy various kits that come with all of the o-rings for the entire rebuild kit, but it's very difficult, what I've seen, to find just this top gasket or just this o-ring. So there's a couple kits that look like they might work. I'll post links in the description, but I have 2 rebuild kits that would work. That looks like it'll work. Ordered and on the way. So I think there's 2 options here. There's Permatex, there's a thread sealant that's safe for fuel and diesel. we could take this nut off and then coat the threads with the sealant and put the nut back on. And people have said that does work. The second option is we can try to take this top cover off and hope that we can reuse the seal. But then we'd have to determine what size O-ring this has. But the bigger problem is the car. So the car is running fine when it's cold. However, after 5 minutes or so, it'll almost feel like it's in limp mode or stuck in third gear. And what I've learned is this truck has been stored since 2018. It's only put on about 4,000 miles. So sitting is not good for things, as everyone knows. And what I initially determined is this O-ring is leaking. Alright, so I don't love this repair, but it's our first attempt. So it's Permatex high temperature thread sealant. Prevents leakages. It's good on gas and diesel. So what I did was basically remove the nut, pull the sensor up as far as it would go, and then coat the inside threads of the nut with the sealant, and then snugged it down. If Toyota designed this and not Bosch or whoever, I think they would have done a different job at this junction. It's just kind of odd to have an O-ring inside. They would have done something where it was like sealed from both sides or something, or you could easily replace the outer O-ring or something like that. Anyways, people said they went this route, tried it, and it fixed the problem. So if it doesn't work, we'll be getting the seal kit anyways in about a week or two, but just in the meantime, hopefully it does work. So I've got some factory manual stuff here. So timing control valve, this is one I mentioned before I think we're having an issue with. I'm sure this will test fine, but we'll do it anyways. Essentially, we're going to look for 10 to 14 ohms of resistance across the two terminals, and then we're going to test it with the battery positive and negative, make sure it clicks. So the timing control valve is actually all the way at the bottom. So let's pull these off first. We're actually going to measure these as well, assuming they don't break off. There we go. These are injection pump correction resistors. So it says disconnect the resistors, measure between terminal 1 and 2, 0.1 to 2.5 kiloohms at 70 degrees. And then the SCV I have here, 1 to 2 ohms, so that's this final connector. Spill control valve here. There's a cap here, and you can adjust like the global fueling, if that makes sense. But it's just going to essentially change the fueling across the board. It's not a specific point in time. Let's get this off here. There we go. So we're looking for 1 to 2 ohms on that. Let me grab my voltmeter. Okay, so this is our spill control valve. This should be 1 to 2 ohms. It's a little high, by about 1 or 2 ohms. I don't know if that's normal or not, but it is what it is. I mean, that's the reading. 3.0, 2.9. I mean, that's pretty close. I don't know. Again, I don't even know if... I can't see the terminals in here, so I'm assuming we're not touching them together. 2.9. I mean, that's pretty close. Slightly high. I guess it's not really alarming. We'll notate it, though. Write down that it was 3 ohms. So next we've got the resistors, which are these two plugs here. So we're going to find them on the bottom and hook them up. Okay, the right side resistor is 1.2 ohms. and it says resistance should be anywhere from 0.1 to 2.5 kohms. So I guess 1 is in between those two numbers. So we'll check the left-hand side resistor next. Okay, left-hand side resistor, same thing, 1.2 ohms. So we're consistent between those two. This doesn't, nothing leads us to believe that anything would be wrong with those. Spill control valve, maybe. A little bit of research on that, but finally we'll do our TCV, the thing we think is the issue. Let me hook up the probes to that one. Okay, we've got our leads down here and there, and we're at 10 ohms, and we're supposed to be between 10 and 14 ohms. So electronically the valve is testing okay, so that's probably why we're not getting a check engine light, because there's nothing wrong with it. So now let's hook up battery voltage, and we should hear some clicking. I just need to figure out which wire is positive. Okay, and now we're testing to battery. The top connector, where it's actually the red wire on top, that's your positive, and then the bottom one's negative. So we can hear it clicking like that. So that seems like it's functioning okay. But again, you know, if it warms up or there's something stuck in there, it doesn't really tell the whole story. So a couple things we can try. We could start the truck like this with it unplugged and actuate this on our own with the truck running. We can also put an extension from the bottom and tap on it while the truck is running to see if that fixes it, makes it worse, changes it, etc. So electronically we're looking okay, other than the 1 ohm high on the spill control, but I'm not too concerned about that. So I'm going to plug all this back in, and we actually have to probably wait a good 24 hours, 4 to 24 to 72 to make sure this is set up. This isn't high pressure, it's just low pressure, so I'm sure even at this point it would probably be okay to run, but I'm not going to take any chances. Unfortunately, you can see this is still leaking from between the nut and the body, so we're just going to have to wait on that O-ring to come. Unfortunately, it didn't work. Alright, so I disconnect the fuel pressure rag here. That's your feed from the fuel filter. That'll drain basically, you know, what's on the top of the filter. And then we're just going to have to, I move this wiring harness out of the way to give us a clear shot on that top portion. This nut is a 32 millimeter, I believe, but it's only torqued to, like, I don't know, hand tight. There's nothing crazy about the torque on this. So I'm just going to disconnect these two hoses. And of course they just pull right off, which is not great. I mean, it should be, you know, stuck on there with the clamp. Spill control valve here, we'll avoid that, and it looks like we've just got these 4 hex bolts, and if memory serves correctly, they are 5 millimeter. So I'm going to find a 5 millimeter socket and pop these loose. I guess I could do 3 of them with this handy dandy right angle one. Nope. Let's get the socket. Alright, we've got our universal joint swivel, 5 millimeter. This was enough to get all 4 loose. We've cracked this nut loose here that I had such high hopes for. And then we're also going to have to remove this, which is, I don't know what this is, a return maybe. And I'm not familiar with what everything is on this thing, because this has a little hose that goes down. You don't want to, well, that can't be on there when you pull the top off, I don't think. Okay. Ah, never mind. Well, we'll deal with this later. Alright, so now we're looking relatively good. We've got a lot of fuel leaking out, which is good. We don't want this to be too full. I'm going to take the rest of this nut off because this cover has to come off without the sensor. Okay, moment of truth. Got everything loose. And now the sensor doesn't want to come out. There's our cap. There's our gasket here. That all looks fine. But here's our problem. It's this O-ring right here. So we got to get this off, measure it, and I've got some Viton O-rings on the way. So we can basically see, this looks like it's broken. That's not good. That's kind of just a locator. That just locates it, you know, right that way. But everything's brittle in here. Make sure nothing gets in this fueling area, in this vat. If there's anything questionable, then, you know, blow it off with a little bit of brake cleaner so it doesn't go in there. I'm okay with that. Now, need to find a pick and get this O-ring off, and then I can put the cap back on. Okay, it must be some kind of like giant trade secret that nobody tells anybody what sizes of seals these are. Like, I just want to order the frickin' O-ring. I don't want to order a whole kit. That's my complaint here from what I found online. It's like people are gatekeeping the O-ring sizes for the KZ injection pump, which is just a little odd. And I don't want to break this because then we can't accurately measure the thing. So let me see if this gets in there. It doesn't stab my finger. That's pretty in there. Let me find a different tool. Okay, so as I figured, this thing is like plastic almost, so it did break, but we do have a good idea of the size, and we can match this up to a Viton kit that I ordered, and find the correct millimeter O-ring for that. That's all I wanted. I just wanted one O-ring to replace that, and then stick the top back on. So here's your little locator pin on the right. That's just where that sits in there. And the O-ring, it just simply seals against this housing, which is kind of crazy. And then this little gasket also that is impossible to find, that nobody wants to share, but that's fine. Now this goes that way. You want the clip to be, or the little pin, I should say, for the connector to be towards you. And that just kind of sits in there like that. So I'm going to leave this just like this until the O-rings get here. I think they're coming in, I think it's 2 days unfortunately, but it is what it is. So I'll just stick these back in loosely so our big seal doesn't dry out, hopefully. And the kit I have should have the big seal, so just in case you know, there's an issue with that, we don't have any problems. Alright, so now that that's done, I'm also waiting on that timing control valve, which is at the bottom. But again, we need to, well, that's going to drain the fuel for sure through the whole pump, and then we'll have to reprime everything. But I did. Okay, just finishing up here. That looks good. And like I said before, I did disconnect the timing control valve, and you know, symptoms were almost identical, but a little bit worse because it was totally disconnected. So we'll wait for those seals to get here, and then hopefully we'll have a non-leaking pump. In the meantime, let's move on to the fuel filter. Alright everybody, so that kind of wraps things up. I want to thank you for watching the series on the landcruiser Prado. I don't know if I'm going to have any more videos on this because there's not much else to do. I'm looking for a buyer, and I got a few interested people, so this thing's probably going to get out of here in the next few days or weeks. So, again, thanks for watching. Please like, subscribe, comment. Tell me what you like, what you don't like, what you like to see. I try to post things that I can't find online anywhere. There's no documentation, there's no walkthroughs, and I try to put those up there for Toyotas, Lexus, and Mitsubishi vehicles. So, thank you. Till next time. See you.